In ray optics, we are going to take up the concept of reflection of light on spherical mirrors. In fact, you people all know most of the concepts of spherical mirrors as far as reflection that is concerned, they are all similar even when you talk about refraction taken in the case of lenses. Similarity, not equality. Remember that. And spherical mirrors, while taking up, we used to consider a concave mirror and a convex mirror. This concave mirror is capable of producing both real and virtual images. That is what is called as a convergent mirror. And the second one is convex mirror, which of course is called divergent mirror, and that can only produce virtual images. We cannot get a real image by that. And out of these two, some common features we have to remember. The mirror formula, whatever we take up, is 1 by u plus 1 by v is 1 by f. That's common for both the mirrors and even common for the image, whether it is real or virtual, that is formed by the mirror. But what makes the difference? While taking up or discussing different problems, one should be in a position to write the correct Cartesian convention. New convention what we people used to follow is, in the direction of the incident ray, all the distances are to be taken positive and the distances are to be measured from the pole of the mirror. And opposite to the direction of the incident ray, all the distances are to be taken negative. When you take this particular concept, while discussing about real image formation in the case of a concave mirror, you can understand well object distance u, image distance v, and even focal length, that is f, all the three are taken against the direction of the ray of incidence. So naturally, all the three values are to be taken with a negative sign. Therefore, if you apply that mirror formula for concave mirror, when the image formed over there is real, that can be written as minus 1 by f is equal to minus 1 by u minus 1 by v. In general, we can write that one now as 1 by f is equal to 1 by u plus 1 by v. When you are finding a virtual image formation in the case of same concave mirror, then no doubt f will be taken negative. U also will be taken negative. But the image is going to be formed behind the mirror. In the direction of incident ray, we used to take its distance. Therefore, we take that value of v as positive. So how to write this mirror formula in the case of a concave mirror when the image is formed over there as virtual by nature? Then what is the equation? 1 by u, that's with a negative sign, plus 1 by v is equal to 1 minus 1 by f. That particular convention one should be thorough with while doing different problems based on concave mirror. If you consider convex mirror, never it used to give real images. Always the image formed by convex mirror is virtual by nature. And thereby, what you people used to observe in this case is accepting the object distance. The other two distances are to be taken positive. So what you can write there, minus 1 by u plus 1 by v is equal to 1 by f. That is the way we people used to write by considering new Cartesian system. That is of course a convention what we people used to take. And in addition to this one, magnification or magnifying power of a mirror, when we discuss that one, no doubt magnification M is equal to size of the image by size of the object, which we write generally as H2 by H1. Or you can even write image distance by object distance, that again we people used to write it as V by U. For concave mirror, the image of course may be formed over there smaller than the size of the object, equal to the size of the object, or greater than the size of the object. All the three possibilities will be finding in the case of a concave mirror. Thereby, magnification may be either less than 1 or is equal to 1 or even may be greater than 1 also. But in this regard, one more point we have to remember as far as the convention that is concerned while writing the magnifying power. The concept is quite simple. If the image formed over there is real, then magnification will be taken negative. That means if the image is formed upside down or inverted, magnification should be written with a negative sign. If the image is formed erect with respect to the object, then we people used to consider that magnifying power or magnification as positive. So what we should understand while writing magnification as far as sign convention that is concerned, the image if it is formed above the principal axis, then the magnification is going to be positive. That is virtual image formation I am talking about with respect to the object. If the image is erect by nature, then magnification will be taken positive. With respect to the object, if the image is formed inverted, upside down, then we people is to take that magnification with a negative sign. And another point to be noted as far as convention that is concerned, all the distances above the principal axis are taken positive. All the distances below the principal axis are to be taken negative. Distance in this particular sense is nothing other than height. Suppose object is placed, that definitely will be placed on the principal axis. In the above, means above the principal axis you will be finding its size. So the size of that object when you consider, that value should be taken positive. And image suppose is formed upside down, that definitely will be below the principal axis, its size will be below the principal axis. In such cases, those distances or heights below the principal axis, we people used to consider that one with a negative sign. So while doing the problem, if you people are perfect and thorough with the conventional signs, whether it is the case of a concave mirror or in the case of a convex mirror, the result of course is going to be perfect. You will definitely be getting the correct answer what is required for that particular problem. Therefore, one should be perfect with this particular convention what we people are following in this topic. If you are perfect with this convention, same convention will be repeated even in the case of lenses as well. The method of taking the convention is same. That time, in the case of refraction of light through lenses, the points are going to be much more easier for all of you to remember. Therefore, let us work out the problems based on these conventional signs, taking them carefully here. I am doing here some of the questions over one after the other rather, and each question I read out, and we are going to discuss the important features related to that, and we shall directly work out each and every number one after the other. Let me just take the very first problem what we people are having. The first problem says an object is placed at a distance x1 from the principal focus of a concave mirror on its principal axis. Object is placed at a certain distance, fine. Usually, object distance and even image distance are measured directly from the pole of the mirror. But in this particular problem, he is giving both the distances from the principal focus of the mirror. So he is talking about an object is placed at a distance x1 from the principal focus of a concave mirror on its principal axis. The image is formed at a distance x2 from the principal focus. The focal length of the mirror is how much? The options are given this way. The first option is x1, x2. Second option is x1 plus x2 by 2, that's average like. Third option is root under x1 by x2. And fourth option is square root of x1 into x2, the product of x1 and x2, under root. That is the fourth option. But the moment you read this one, you can easily get your mind, it is Newton's formula. When the distances to the object as well as the image are taken from the principal focus of the concave mirror as x1 and x2, then the focal length of that mirror f is equal to square root of x1, x2. That is the general formula one should remember. But okay, let us work out even that value also. If I take 1 by u plus 1 by v is equal to 1 by f, because object is real, image also is real like he is talking about, and of course we know pretty well in this particular case focal length of that mirror what has been given is to be taken negative. When all the three are negative by nature, 1 by f is equal to 1 by u plus 1 by v prevails as it is. So I now can write 1 by u plus 1 by v is equal to 1 by f. That is the mirror formula for us. What are these two distances now to be taken according to the given values? Look at that one. 1 by, I write this one f minus x1. This is 1 by f minus x2. That now is going to be 1 by f. So this is the way we people used to work out by taking u and v according to the given values of x1 and x2. Now if you rewrite the same this way, f minus x2 plus f minus x1 whole divided by f minus x1 into f minus x2 is equal to 1 by f. Now simply cross multiply this equation first. This is already 2f into f, it now becomes 2f square here. Fine. Now minus f x2 minus f x1. That now is going to be f square minus f x2 minus f x1 minus into minus plus x1 x2. Now on both sides minus fx1 you can cancel, minus fx2 you can cancel. Bring this f square this side so that you will be left with f square. It's 2f square minus f square. That now becomes f square. That is equal to x1 x2. What is the focal length of the mirror? That is the question. So f now becomes square root of x1 x2. That is the correct equation. But actually this I have reminded you how to just acquire this result. But in reality this particular concept comes under Newton's formula. If you can remember that Newton's formula directly, it's a very simple concept. Focal length is equal to root of x1 x2 when x1 and x2 are the distances to the object as well as the image from the principal focus of the concave mirror. So this is the equation of course for frequency, this one focal length in terms of object distance and image distance which are measured from the principal focus of the concave mirror. Now this value, this equation in fact is in coincidence with the fourth option provided to us in the problem. So we can write directly the answer for this particular problem as D. So this is the methodology one should remember, and this is the ultimate formula. This also is called as Newton's formula. So remember this one directly as Newton's formula so that you can avoid this type of calculation in the examination. So this is the first problem what we are having in this order. Check the second number there. A man has a concave shaving mirror of focal length 0.2 meter. How far should the mirror be held from his face in order to give an image of twofold magnification? Twofold magnification is equal to 2, that is the concept. So you can directly understand in this case, when the object is placed in between the pole and principal focus of a concave mirror, the image thereby formed will be virtual, erect, formed behind the mirror, and important most feature of that image is it is a magnified image. How many times that is going to be magnified in this particular case? He has given magnification is 2, twofold. That means 2 times enlarged image than the object we people are getting in this case. What are the options provided? First option is given 0.1 meter. Second option is given 0.2 meter. Third option is given 0.3 meter. And fourth option is given 0.4 meter. That is the case. Now recollect once again from the concave mirror, what is the general formula for its magnifying power or magnification produced in the case of the concave mirror when the image is formed there? What is that magnification here? Magnification is F by magnification is equal to F by F minus U, I can write. What for you people can definitely understand in this case? 1 by U is 1 by U plus 1 by V is 1 by F, fine. But magnification in this case is mentioning it as 2. So magnification is 2 means V by U is equal to 2. So what we have done in this particular case, magnification general formula is V by U. Then V is equal to M into U. We have substituted that value in that mirror equation and we have simplified the total lot. After doing that, we be getting the magnification in terms of focal length and object distance like this. So what you should understand in this particular case is going to be F by F minus U will now be the correct magnification of that image. What is the focal length given now? Focal length is given 0.2. No doubt 0.2 meter, but it is concave mirror, mind that point. Concave mirror's focal length will always be taken with a negative sign just because of the convention what we are following. So F will be negative for concave mirror and F always will be taken positive for a convex mirror. So automatically we can write in this case M is going to be 2, no doubt. And F is now should be taken as 0.2 with a negative sign. This also is 0.2 with a negative sign minus U. Now just cross multiply this whole thing please. This is now 0.4 with a negative sign minus 2U is equal to 0.2 with a negative sign. So what can we write now? Minus 2U is equal to 0.4 going that side, 0.4 minus 0.2, it's going to be 0. With what value? Positive value in this case. Now what will be the value of U, the question? It definitely going to be 0.1 meter now. Negative obviously, because object distance always is taken from the pole of the mirror. That according to the convention, we are going against the direction of incident ray. Then automatically the value is to be taken with a negative sign. Of course, the same I have got here. But what is the object distance is the question. At what distance he should hold the mirror? That is the concept. So what can we write now? Distance is equal to 0.1 meter. So at what distance it is supposed to be held so that the magnification becomes twofold? That is the question. So at what distance we have to place the mirror means it should be placed at a distance of 0.1 meter as such. So out of all the 4 options, the very first option is exactly the same value given in the problem. So we can directly take up the correct answer for this problem number 2, that is going to be the first option. So only thing you should recollect directly is m is equal to f by f minus u. When object distance is known to you, focal length is given to you or known to you. So without going for the value of v there, simplified form for magnification is f by f minus u. That is the concept we have to